All right, I have a meter sent into the channel for review. I've reviewed several of the Kaiweets meters. This is their new one. This is a 20,000 count meter, so it has a very nice resolution. And it's in the same form factor as their 6,000 count meter. I forget what part number that is. I did review that one. But this is their new 20,000 count meter, the HT118E. And so we'll take a look at that. We'll be comparing it against another meter. I think this is probably the best meter to compare it to in its price range. This is the Anning AN870. I really like this meter, and I think it's in about the same price range. If I was going to get a 20,000 count meter and I was willing to spend a little bit more money, I've always recommended the Unity HT118E. I've had several of these, and I really like these meters, but we're not going to be comparing it with this one today. We'll use this. All right, it comes in a little carrying case, and user manual. Here's the meter, batteries, probes. I won't be reviewing the probes. They're just the generic probes that you'll always get. You know, they're not great. They're not terrible. It does come with a temperature probe as well. So real standard stuff. The same stuff that you would get with something else. All right. So let's take a look at the meter. Let's remove the display sticker. There we go. All right. It does have a little bail on the back, so I could flip it up and get the glare. Okay, no batteries in it right now. Switch seems good. Seems pretty positive on each setting. Off is all the way to the left. Buttons are firm. Yeah. All right, let's put some batteries in it. It uses 2 AA batteries. And there we go. Nice big display, big chunky letters. It is a dual display for some functions. So this would, let's see, let's look at each thing. For AC volts, oh, this is DC and AC, I think. DC, yeah, DC, AC. Oh, when you go to AC, it says hertz as well. Okay. Millivolts. Millivolts is the same way. Hertz gives you frequency and percent duty cycle. We have continuity. I do want to check out the continuity. My major complaint of Kaiweets in the past has been their continuity check has been very slow. Something that I just don't like. So we will try to put in. Oh, there it goes. So I'm going to be using some gold-plated Probe Master tips. Okay, so give it all of the chance you can get, and we'll see how fast the continuity is. Oh, there we go. Very nice. Okay, they passed the continuity test. So the first Kaiweets meter that's passed the continuity test for me. It is latched, and you get a beep and you get a flash, and it's nice and fast. So very good. They finally got one. All right. Let's see here. Ohms. Display. Okay, they have a diode check. We might as well do the diode check since we're right here. I have a diode check board right here, and let me change probes. Okay, the spacing is 0.75 standard spacing, which is good. And we will go to the first diode here, 0.3. It's a germanium diode, so 0.3 is correct. We'll go to a silicon diode, 0.62. We'll go to a red LED, 0.16, and we'll go to a blue LED, and does not have the voltage range to do blue. Let's see what the maximum voltage it's giving out here. Yeah, we're getting 2.5 volts, so it has a 2.5 volt compliance. Pretty standard. Pretty rare that a meter will do a blue LED. It does light it up, of course, because it's probably a milliamp of current. We have a capacitor check. We have Fahrenheit and centigrade. That's kind of nice. Microamps. It does have a microamp scale. That's good. Milliamp scale and an amp scale. It does have also a 10 amp range, and then it has a non-contact. See, there's electricity in my fingers. It has a non-contact AC detection on the front. It's detecting the 60 hertz from me being an antenna. All right, so let's hook it up. Let's put it side by side with something and see how it does. All right, I have 3 meters. Let's go ahead and put some kind of volts on it. Let's say we have 1 volt, and Kaiweets is a little low. Let's see, let's do 2 volts. 3 volts. So we can try to get the most range out of this thing. So because it's a 20,000 count meter, if we go to 1.9 volts, that will give us the best resolution on the meters here. So there you go. Let's go to 2.9. 3.9. I think we need to go up to 19.9. Let's see if we can do that. Let's see here. 19 volts. There you go. I think we can go high on this thing. 109. Let's go back to 100 volts here. So we seem to be getting more digits out of out of this one than the other ones. That's kind of interesting. Let's go down to 90. There you go. Interesting. There we go. 11. All right. I mean, they're all reasonable, right? Kaiweets a little bit low. Let's see here. Oh, this does have the backlight on. Is that a... No? Is that... Oops, I turned on the flashlight. There we go. Turned off the flashlight. How do you do the backlight? Is the backlight on all the time? That's going to drain the batteries down. Let's turn this back on. Maybe I pushed a button. No? Backlight came on. I don't know about... There's a button here. Let's click that one. Wow. Yeah, I'm not sure about that. I wouldn't want the backlight on all the time. Only when you want it, like this one. Yeah, I don't know about that. I don't remember if this one has a backlight or not. Yeah, I think it does. Let's see. Yeah, this one has a backlight as well. I don't like the backlight on this one. The backlight here is much nicer. All right. Let's do some small voltages. Let's see here. 60 millivolts. And, oh, I pushed the hold on this one. There we go. $60. How about 1 millivolt? And 100 microvolts. Okay, so now we need to go to the millivolt range. We'll go to the millivolt range. We'll go to the millivolt range. And yeah, this guy's winning. I'm not sure what those other guys are doing. Let's see here. Let's go up to a mil. Oh, what is? Oh, this is AC. I'm sorry, I had it on AC. I figured the Agilent should be perfect. All right. All right, there we go. There's millivolts. There's millivolts. All right, so let's do 11 millivolts. 11 looks good. And I'll do 1 millivolt. All right, 1 millivolt looks fine. And then we'll do 100 microvolts. Oh, and we can go down here. Let's see here. Let's see, this is 100 microvolts. And yeah, I'm surprised about this one. This one seems to be hanging in there, and this one has just gone away. Oh, yeah, it's having a hard time with maybe 100 microvolts. Let's do 200. And we get a nice number of digits here. We're not getting the digits here. I'm not sure why. Let's do 1.9, 190 microvolts. Yeah, we're kind of losing resolution on the Kaiweets. All right, let's go back to 1 millivolt. All right, let's measure some ohms. We'll look at the 0 here. I'm shorting out here, and so we're measuring that. So there's no drop in the leads here. So we'll go over to the box. We have it set at 100 ohms. 200, 300, 400. Let's do 19. Let's see what happens when it does that. Yeah, we get all the digits. 1.9K. All right. So 20,000 counts sometimes is to your advantage, and sometimes it doesn't matter. All right, let's go to 1K. Very nice. We'll go to 10K. Very nice. Go to 100K. Very nice. And we'll go to 1 meg. So seems to be good with ohms. All right. Let's do the same thing with the 870 here. We'll give it 100 ohms. 200, 300, or getting more digits in general. I think the use of digits is better. Okay, we'll go to 1. Very nice. 10, 100, and 1 meg. Oh, we're off a little bit, and there we go. It's just settling in. Okay, very nice. All right, I'm going to be running some AC signals into here. We have 1 kilohertz coming in, 50%. We were running a sine wave. Here's a square wave. All right. I'll leave it on sine wave. We'll go to, that was 1 kilohertz. Look at 10 kilohertz. Let's go to, let's see here, let me change my scale here. 40 kilohertz. Let's go up to 100 kilohertz. Okay. Let's go to Let's go to a megahertz. All right. I think both of them were spec to 10 megahertz. Let me move my decimal over. Here we go. 10. This is 10 megahertz. And both of them are failing at 10 megahertz. I might need more amplitude. Let me bump up the amplitude. I was at 100 volts peak to peak. Let's go to 500. No, that didn't help. Frequency. So we need to back off of the frequency. Let's go to 4 megahertz. Yeah, 4 megahertz. 4 megahertz is fine. 5 megahertz. Fine. 6. And 8 is bad. And 7 is bad. And 6 works. So they probably have the same chip in them. I mean, I don't know. Anyway, so 6 megahertz is fine. So let's go back to 1 kilohertz. All right. Now let's measure, let's see here. Let's measure AC volts. Here, and I'll go to here, and push the button. So now we're at AC volts. Let's see how they compare. All right, let me load this down first. Okay, so we should be measuring 500 peak to peak. Let me do RMS. Let's see here. Let's do amplitude. Enter number 100. Let's see here. Cancel. Let's see here. Enter number 0.1 volts RMS. Okay, so we're here 100 millivolts RMS, and so yeah, there we go. We got a nice 100 measuring the kilohertz here. Yeah, Kaiweets is doing really good on this AC test. 100 millivolts. Okay, let's up the frequency then. 10 kilohertz. Yeah, 10 kilohertz, it's not measuring anything. Okay, that's what I thought. 6 kilohertz, no. 4. And it's too low. 2. Yeah, about 2 kilohertz. Both the meters are working at a kilohertz, but not much above that. So that looks all reasonable. Let's go down to something like 60 hertz. Enter number, no. Frequency, yeah. Enter number 60 hertz. There you go. And yeah, they're measuring both fine. So I do like the dual display for AC. That's nice. I should move that over. Yeah, I'd say they're both doing about the same for AC, except you get an extra display. Okay, let's measure some precision capacitors. These are 0.3%. Let's measure this one. See how he does. And this one is 15720. 157, yeah, not too bad. All right, let's go to 0.78. A little high. All right, how about a... This is a 8347. Not bad. And this one is a 10. 10 on the nose. There you go, 100. Nice. Okay. So these are some fancy Soviet Union high precision capacitors that I have. And I know people want to see the 2 meters side by side, so let's do it. Let's do it for the Anning. Let's see, where do we get? Oh, here we go. Got it here. And we will go to capacitance, which is right there. Okay, well, it's measuring 100 also. Okay. And this one is 3847. And this is 1572. And the 0.598. Okay, 6. So, seems like this one was a little faster. Maybe it was just me. But, yeah, they're both measuring about the same. All right, that's as far as I'm going to go. If you'd like a more in-depth review of this meter, I would say go over to Kerry Wong's channel. He did a teardown of this. I think he said the input protection is a little bit lacking, probably on both meters. So, you know, they always put cat and stuff on them, but I think if you really want to use it on high voltage stuff, you should get yourself a good meter. But these are fine for bench use. But he did a lot more testing, I believe. Yeah, go watch his channel if you like really in-depth reviews. Otherwise, I would say my opinion is they're basically equivalent. Differences is this one kind of has a more industrial feel to it. This one has, let's see, yeah, they're about the same case. They have a kind of a hard rubber kind of plastic thing surrounding them. This one does have a dual display, so that's a plus. This one has a little bit larger display. That's a plus. This one has a better backlight than this one. Yeah, I don't know. Let's see. This one has the non-contact live switch. See, this has amps, 20 amps. Yeah, this will do 20 amps. This will do 10 amps. Okay, if you want to do that. This one does have a non-contact as well. Over here, it has a, and it doesn't get fooled by my hand, but it does have a non-contact sensor here as well. Oh, there we go. I didn't have the switch all the way. Yes, so it does. It always detects. All right, so they both have that. Yeah, I don't know. I think it's kind of you know, 6 of one, half a dozen of the other. Which one that you would like?